Welcome to the math record. Today I'll be covering the third convergence test, the limit comparison test. So if we're given two functions f of x and g of x, and we're taking the limit as x approaches infinity of f of x and g of x, and the limit comes out as a number L that is between 0 and infinity, then either f of x and g of x converge, which I'll represent as a C, or f of x and g of x diverge, which I'll represent as a D. So it's either one or the other. They either both converge or they both diverge. So it's a similar idea to the comparison test, but now we're going to deal with limits. But they do pretty much almost the same thing. So x equals 1 to infinity. Let's say we want 1 over square root x plus 5. And we want to know if this converges or diverges. Well, if we think about this going to infinity, it doesn't matter that the plus 5 is there. So we think about what we want to compare it to is 1 over square root x. And let's call this one our f of x. And let's call this one our g of x. It doesn't really matter. You can assign any to each, but I like the smaller version I like the easier one on the top. And on the bottom is 1 over square root x plus 5. And then we take the limit as x approaches infinity. So the limit as x approaches infinity, dividing is the same thing as multiplying by its reciprocal, so this simplifies to square root x plus 5 over square root x. So you could just rewrite that as square root x plus 5 over x. And if you plug in infinity here, the coefficients are 1, so it's going to approach 1, and square root of 1 is 1. So that means our limit L, which is 1, is between 0 and infinity, so it satisfies our limit comparison test. So are they both converging or are they both diverging? Well, if we look at 1 over square root x, that's just the same thing as 1 to the power of 1 half. I mean x to the power of 1 half. And the p-series says that if x is greater than 1, it's converging. Well, it's not, so that means this has to be diverging. That means our original is also diverging by our limit comparison test. Okay, let's try another example. Let's say we have infinity, x to 1 to infinity, of 2x squared plus 1 divided by the square root of x to the power 7 plus 5. Okay, now let's think about which one we want to use. Well, square root x and square root 7 on the bottom with the radical. So that's x to the power 7 over 2. So that's the same thing. So subtracting 2 from 7 over 2, that's going to be 4 over 2. 7 over 2 minus 4 over 2 is 3 over 2. So that's going to be 1 over x, 3 over 2. So we're going to compare this, which is going to be our f of x, to our g of x. So the limit as x approaches infinity of f of x, which is 1 over x to the power 3 over 2, divided by our g of x, which is 2x squared plus 1 over square root x to the power 7 plus 5. Now dividing the same thing as multiplying by its reciprocal. So this could be written as square root 7 over 5 divided by x to the power 3 over 2 on the bottom times 2x squared plus 1. This simplifies to 2x to the power of 7 over 2 plus x to the power of 3 over 2. So this compared to this, if we taking the limit, well, the coefficient here is 1 because taking the square root is still 1. Then 1 over 2 is going to come out as 1 over 2. Well, 1 over 2 is between 0 and infinity, so this satisfies the limit comparison test. So are they both converging or are they both diverging? Well, looking at f of x again, x to the power 3 over 2. 3 over 2 is greater than 1, so if it's greater than 1, the p-series tell us that this is converging. So if this converges, this also converges. And that's basically it. In the next video, I'll cover the fourth convergence test, the ratio test. Thanks for watching.